This is day 13 of Advent of Code 2023, and this challenge is called Point of Incidence. With your help, the Hot Springs team locates an appropriate spring which launches you neatly and precisely up to the edge of Lava Island. There's just one problem: you don't see any lava. You do see a lot of ash and igneous rock. There are even what looks like grey mountains scattered around. After a while, you make your way to a nearby cluster of mountains, only to discover that the valley between them is completely full of large mirrors. Most of the mirrors seem to be aligned in a consistent way. Perhaps you should head in that direction. As you move through the valley of mirrors, you find that several of them have fallen from the large metal frames keeping them in place. The mirrors are extremely flat and shiny, and many of the fallen mirrors have lodged into the ash at strange angles. Because the terrain is all one colour, it's hard to tell where it's safe to walk or where you're about to run into a mirror. You note down the patterns of ash, dot, and rock hash that you see as you walk, the puzzle input. Perhaps by carefully analysing these patterns, you can figure out where the mirrors are. So for example, there are these two right here, and this is the same as this, these two are the same, this one is different from this, so it can't be that way, but these two are the same, this and this is the same, this is the same, this is the same, but then that one doesn't have anything. Okay, so to find the reflection in each pattern, you need to find a perfect reflection across either a horizontal line between two rows or across vertical lines between two columns. In the first pattern, the reflection is across a vertical line between two columns. Arrows on each of the two columns point at the line between the columns, so these two are the ones which are reflecting on each other. In this pattern, the line of reflection is the vertical line between columns 5 and 6. Because the vertical line is not perfectly in the middle of the pattern, part of the pattern, column 1, has nowhere to reflect onto, and can be ignored. Every other column has a reflected column within the pattern, and must match exactly. Column 2 matches column 9, column 3 matches 8, and so on. The second pattern reflects across a horizontal line instead. So these two, and they reflect perfectly up to here, but the first one doesn't have anyone to reflect onto. This pattern reflects across a horizontal line between row 4 and 5. Row 1 would reflect with a hypothetical row 8, but since that's not in the pattern, row 1 doesn't need to match anything, and those are the ones which it matches on. To summarize your pattern notes, add up the number of columns to the left of each vertical line of reflections. To that, also add 100 multiplied by the number of rows of each horizontal line of reflections. In the above example, the first pattern's vertical line has 5 columns to its left, and the second pattern's horizontal line has 4 rows above it. A total of 405. Wait, add up the number of columns to the left of each vertical line of reflection. Okay, so for the vertical one, it's basically this number, and then whatever it is to the left, so 1, 2, 3, 4, 5. And then for horizontal, 100 multiplied by the number of rows above each horizontal line. So this would be 0, 1, 2, 3, 4. Okay, so find the line of reflection in each of the patterns in your notes. What number do you get after summarizing all your notes? So we're going to start off by grabbing this and pasting it into our input. So for line, so I think we need to change how we're reading the input. It's we currently just go by line by line, but because it's multiple grids, we need to change that. So maybe just print input, so we can just see what it looks like. Okay, so what we'll do with this, we'll create new grid equals list. For line in F, we will do if line does not equal just that, new grid dot append line, and we'll just do else input dot append new grid equals list, and we'll do if new grid input append new grid. So let's see what input outputs now. Need to do dot rstrip here, and okay, well that got added. This is a line. Oh, it's because it's probably had a new line in it, so we'll do rstrip first there, and then we will add. There we go. Okay, we've got our grid. So we will do score equals 0 initially. We'll do for grid in input, and to help out with this, we'll actually make this rows, and we'll also create a columns list, and that'll be for I in range rows 0, for row in row column equals list, column dot append row I, that should be row range length of row, and then columns dot append column, and let's print columns for row in rows. That's one we wanted. So let's see if that matches this. Hash dot hash hash dot hash. Okay, cool. We've got both rows and columns, just so we don't have to do weird index stuff while we're working on this. Okay, so we're actually going to create a function for this because the code to find the reflection is the same for column and row. So we'll do def reflection. This will take in pattern. Okay, so what we need to do is start off with the first column, and we need to find, or we need to kind of brute force over all columns and see if they reflect on each other. So I guess we'll do for index 1 col 1 in enumerate pattern, and this will be enumerate pattern up to the last one. Then what we need to do here, do for index 2 col 2 in enumerate, I think this will be pattern 1 like this, then it will be index 2 plus equals index 1 to make up for the starting number there. So then what we'll do is, if, actually no, looking at this, makes more sense to just do a range. So length of pattern -1, so index 1 in range of that, index 2 in range of pattern, length of pattern, and this will be 1 to pattern, I think. So if pattern, actually this should be reversed. Actually, how should this work? Actually, no, yeah, this is correct. Although it should be. So we need to start at index 0, and then we're looking at like the very end, or the end -1 or something, and then it goes inwards to each other. Okay, we'll keep that as just the length of pattern. So I think I've confused myself a bit by doing this. So I've got the first index, and we've got the second one. Well, this is going to be used on the length, I think. So I think we'll have reflection found equals false in here. Actually, this will be equals true. Then we do if pattern index 1 does not equal pattern index 2, reflect found equals false. Then we break, and then we do if reflect found. We then return index 1, because that's either the column or row which is to the left or at the top. And if we complete that, then we do return none. So now back to down here. We start off with for rows and input columns. So we start off here. Actually, no, back to here, rows, and we do row index equals reflection rows if row index is not none, score, and this is rows, so that's the times 100, so score plus equals 100 times row index. Wait, is that right? Row index, so this like this. So if it's here, that would be index 2, so we then need to do +1, and that's right, because if it's row index 3, then it's, or index 2, that means there are 3 rows, and you're including the one you're on, so it would be 1, 2, 3, but it would be index 0, 1, 2, so 2 plus 1, 3. Okay, that sounds right. And then we do the same thing here. So we're now passing columns in, column index not none, and this will just be column index like that. Then we return score. No idea if that works, but let's run it. Got 0. That's always good. So let's see what's actually happening here. Okay, so this doesn't work. Let's take a look what it does. Maybe I should also print index 1, index 2. Okay, that definitely isn't working. Well, it's not. That's definitely not how it should be. But what is it that I'm trying to do? Well, actually, I just noticed this should be dot join, right? Oh wait, it should be down here. Okay, now looks how it should be, but still not working, obviously. So this break is probably the issue. I'm starting to confuse myself with this a bit. I'm actually thinking about this. This outer loop might be the offset number, and then this one is index. So we'll do index. Well, actually, this will start at 1 and go until there. So then index, this will be index plus offset, and basically just do that. I think that's how it'll work. No, that doesn't make sense. Okay, maybe I need to change how this works. Let's do index 1 equals index, then index 2 equals index plus offset, just so I don't have to keep writing this stuff out. Then I can actually test it a bit easier. Okay, so maybe I don't need a break from it. Let's try that. Okay, out of range, index 2. We will do that, so that's index plus offset. If index less than length of pattern and this. Actually, that's probably a good time to break. 4. Okay, so definitely not 4, as in both of those. Okay, so I got the first one, but not the columns one. So I'm surprised that it actually worked. I'm curious what number this was. Let's see what offset was. Okay, offset was 4. So maybe that is what we're meant to return. Oh, actually, here. 206. Why did that change anything? What? Wait, this one's meant to be returned none. But then, why are we getting that big number? Okay, so, right, index 1. That kind of makes sense now. So 1 would return a 2, but I got no idea. Actually, returning index does make sense, because the middle one, we're going from lowest to highest. So we're going, okay, so 0 is not in it, so that's out. Then we start on 1. Then we're going 1, 2, 3 to here, and then reflects. Is it this one? Alright, it's this way. So 1, 2, 3, 4. Well, one of them, I can't remember. Well, let's print index. Don't need to print when it turns none. Well, they're now saying 0. What? I'm so confused. Print row index. Print column index. If a bunch of zeros are being returned. Okay, it's doing the +1. Okay. Okay, so that makes sense. Because we're doing the +1s there. Oh, actually, for this, should be like that. Ugh. Had the wrong condition there. And it should be index 2. Okay, this logic is wrong. So we're currently just doing 1 apart, then it's 2 apart, and so on. Oh, actually, I have an idea. Wait, no. Okay, so we've got offset. Maybe I'm understanding this wrong. So we've got the index 1. Now, index 2, what does this need to be? We're going to change this so it's like this now. So we have, it can be 0. Okay, let's instead just print the indexes. I just want to see what that looks like. Yeah, so obviously that wouldn't work. So we want it to be reflected, but I just can't visualize the reflection for this. So we at least need a +1 here, but then that obviously doesn't work. What does it look like if we just do that? No. Just to see, yeah, so this number stays the same as expected. How, I don't know, maybe instead of going up we go backwards, minus index. Ooh, actually that nearly worked. You can see it's going closer and closer to the middle. Ooh, plus offset? 00162534. I think we might have found the solution. But then this number can actually go outside of the bound, so we'd have to do if index 2 in range length of pattern. Although that now, if not in range, still returning 202. So I think we have found, like especially this part, we've found how to actually create the proper range, I think. Like 0, 5, 1, 2, and 4, like this. I think that looks good. Maybe we need to return offset. Interesting. 110. Maybe we take a look at what this is doing. Print index 1, pattern index 1, index 2, like that. Oof. Okay, that's not working as expected. Let's get rid of that print, or just comment it out. Wrong one. Okay, so that happened on the very first instance of this, I think. So 1, 4, 2, 3, like that. And where did that happen? That was here. Yeah. So that reflected with this, and then these two together. But then this returned 0. Maybe we should be returning this number? Okay, yeah. 3, 4, 3. That's definitely not working. Actually, maybe this just needs to be changed to if, instead of breaking, because that's getting out of this whole loop, because that could be causing an issue. Maybe we just need to put that into here. If index in range, then we do that. And this is and pattern in. This index out of range, but what if index 2 is in this? Oh right, okay, remove this. Now run it. Wait, is that the correct number? 405. Oh, okay, we've now got the correct number. So let's go grab the input. I already had it open. And now let's paste it into here. And hopefully this is the correct answer. 33047. There we go. That is the first part done. Now on to part 2. You resume walking through the Valley of Mirrors and smack, run directly into one. Hopefully nobody was watching, because that must have been pretty embarrassing. Upon closer inspection, you discover that every mirror has exactly one smudge. Exactly one dot or hash should be the opposite type. In each pattern, you'll need to locate and fix the smudge that causes a different reflection line to be valid. The old reflection line won't necessarily continue being valid after the smudge is fixed. Here's the above example again. The first pattern smudge is in the top left corner. If the top left hash were instead a dot, it would have a different horizontal line of reflection. With the smudge in the top left corner repaired, a new horizontal line of reflection between rows 3 and 4 now exists. Row 7 has no corresponding reflected row and can be ignored, but every other row matches exactly. Row 1 matches that, and so on. In the second pattern, the smudge can be fixed by changing the fifth symbol on row 2 from dot to hash. Now the pattern has a different horizontal line of reflection between rows 1 and 2. Summarize your notes as before, but instead use the new different reflection lines. In this example, the first row's new horizontal line has 3 rows above it, and the second pattern's new horizontal line has 1 row above it, summarizing to the value of 400. In each pattern, fix a smudge and find the different line of reflection. What number do you get after summarizing the new reflection line in each pattern in your notes? I'm not sure if I fully understand this. So you discover that every mirror has exactly one smudge. Exactly one dot or hash should be the opposite type. In each pattern, you'll need to locate and fix the smudge that causes a different reflection line to be valid. The old reflection line won't necessarily continue being valid after the smudge is fixed. Okay, so this one and this one, if this gets changed, then it works. That's what it's saying. But it's saying, okay, each mirror has exactly one smudge. So the pattern smudge is in the top left corner. So you have to change one thing. How does that work with this? So we need to, okay, we've got this. We'll change it so reflection smudge equals 0. And then we'll copy everything in part 1 to part 2. But then when we run it, we will pass in 1. And then here we will do total smudge equals 0. And if it doesn't equal, so we no longer need this, and we do total smudge. And this will be, so we're going to now iterate through the lines, so each character in the line. So this will be plus equals length of this, it's going to be, we'll do for cell in, so we want to iterate over both of them. So this will be the index of each individual cell. So this will be what do we do? Pattern. Do index 1. So in this, we want the length of this, but then we want to go over every single index in this. So this will then be range, and then cell. Is that too many? Oh yeah. Okay. Can you change that around? Then we do if pattern index 1 cell does not equal pattern index 2 cell, and then if total smudge equals smudge, I think. Let's change this to the original one and let's see what we get. 45 400. Wait, is that? Okay, that is correct. So we still got 45, and now we've got getting 400. So let's change it to this and let's see if 32,700 is correct. And it's not. It's too high apparently. Okay, we got it right there. Double check this. Let's take a look at how these numbers are working again. Index 2. And we'll just do a divider there. Oh, I want to do it on the original one. Okay, well those numbers are way too high. Okay. Should this maybe be changed? We can see that it's overlapping. So should we maybe change this? Like if index 1 is greater, let's just get rid of these. If index 1 is greater than index 2, break. Should we do that? Okay, we've got same results. Now will that fix it? That look Are those the same results as before? What number did I put in before? 32700. Okay. And answer was too high. So if we do this, and then we print index 1, index 2, what will that now do? Or how does that look? So that does look right now. Okay, let's get rid of that. For the sake of curiosity, what happens if we increase this to 2? Okay, so that is wrong. Just wanted to see if that did anything. That does ruin it. Actually, we'll do this, and then increase it to 2. Does that change anything? It stays the same. Okay, let's try the actual input now. That's higher than before, so that doesn't work. Although, let's just put numbers in. Yep, too high. It's all good. Let's change this back. That's 3306. But then that goes down, but that was also too high. So there's exactly one smudge. Oh, it's hard to test this because it runs so many times that you can't really look at where it is in like a certain grid, because it just runs so many times. It's going to do so many outputs, so it feels like it has to do you have to do a lot of guesswork to get things right. Oh, wait a minute, I did one here but not here. Okay, well now that just gives nothing for the test one. Interesting, that worked for none of them are working. So it worked for the test one before because the initial one it returns 4, and then just ran that again, so it returned 4. Okay, so how does this work for this one? Okay, so what happens if I change it to this and then run it? Is this okay? It's still 0, so it just straight up doesn't work. Nice. Oh, actually, this might bring us back to if index 1 is greater than index 2, break. Maybe that's... Ooh. Okay, 28806. And there we go. We have now got part 2 of the 13th day completed. So if you like this video, make sure to like and subscribe so you don't miss out on me completing the rest of these challenges.